Hello, everyone. Today, we continue to illustrate the exercises for Chapter 3. Last time, we have reviewed the exercises for Chapter 2 and Chapter 1. Now, we will look at the questions of Chapter 3, the data link layer. Then, we will review the exercises for Chapter 4, the MAC layers. Now, look at the question 1. In ARQ protocol is actually, in fact, sometimes called the go back N protocol. It uses 7 bits to code frame sequence number, then the maximum transmitting window size is C. If using 7 bits, then the maximum transmitting window size is 2 with the power of 7 minus 1. So 127. Okay. Fill in blank questions. As a bit stuffing scam in HDLC protocol, whenever the sender's data link layer encounters how many consecutive ones in the data, it automatically stuffs a 0 bit into the outgoing bit stream. HDLC, if bit stuffing scams in HDLC, if the sender's data link there encounters 5 consecutive 1 bits in data, it automatically, for example, if in the bit stream, the scams if this stream is to be transmitted streams, then for the sender, at the sender end, it scans the bit stream. It encounters 5 consecutive here, 5 consecutive, then it automatically stuffs a 0 bit. It automatically insert a 0 bit into the outgoing bit stream. That is a bit stuffing, 5 consecutive. Okay. Question 2. For go back N ARQ protocol with 3-bit frame sequence number, the size of receiving window is so what? Question 2. For the size of receiving window is always 1. For go back N ARQ protocol, if 3 bits frame sequence number, the size of receiving window is always 1. It's always 1. Somebody asks, why not 7? The maximum transmitting window size is, if this number is n, right? The maximum transmitting window size is 2 to the power of n minus 1. This is transmitting window size, right? Okay. But here asks, sorry, transmitting window here. But here is the size of receiving window size, right? Receiving window. The size of receiving window is always 1. Okay. Question 3. For ARQ protocol, 3 bits are used to describe a frame sequence number. Then the maximum size of sending window size is the 7. Here is sending window. Size of sending windows is 7. That is 2 to the power of 3 minus 1. Okay. So please look at the questions carefully and distinguish which window size, receiving or sending window size. Sending is the transmitting window size. Okay. That is, they are different. Okay. Short answer questions. Short answer questions. Short answer, no short answer questions for this chapter. Okay, comprehensive application questions. A channel has a bit rate of 4 kilobps and a propagation delay is 20 milliseconds. For what range of frame sizes does stop and wait protocol give an efficiency of at least 50%? If a channel is a bit rate, okay, that says bit rate capital C is known, 4 kilobps. The propagation delay, TP, propagation delay. Here T means time, P means propagation delay, propagation. TP is 20 milliseconds. For what range of window size? What range of window frame size? Here is the frame size, right? Frame size we denoted by capital L, F, LF. What is the LF? The window size. That's stop and wait protocol. The efficiency is at least means larger than or equal to 50%, right? So let's look at the answers, okay? Answer is the frame transmitting time denoted by TS. The propagation delay TP is 20 milliseconds, and the bit rate, say, is 4 kilo bps. Then efficiency denoted by eta is TS divided by TS plus 2TP. Okay, why? Look at this. This is stop and wait protocols. So if the transmitting time of a frame is TS and the propagation delay is from A to B is TP, then B to A is also TP. So this term is TS plus 2TP. And the efficiency is TP divided by TS divided by TS plus 2TP. That is the efficiency, okay? TS divided by TS plus 2TP. That is why we use this equation, eta. Okay, it's eta. Is eta. So eta is larger than 50%. So TS is larger than or equal to 2TP. TP is 20 ms. So TS should larger than or equal to 40 ms. So the frame size LF or LF frame size, the LF, okay, LF, right? LF equals TS times capital C, the data rate, the bit rate, right? TS times capital C should larger than or equal to 40 ms times data rate is 4 kilo bps. So the frame size should larger than or equal to 160 bits. Right? So For example, if these questions will emerge in the final examination, but with different numbers, can you solve the questions? If the numbers is different, I believe you can you can solve the questions. Okay. Okay, this is the answer for question 1. Do you understand? Okay, if you understand, we continue to the next question. Next question says, for satellite channel, the data rate 1 megabps propagation delay is 250 milliseconds. The length of data frame is 2000 bit. So just now, the frame size is not known, but now, the second questions, the length of data frame is known. So assume that error rate, length of acknowledgement frames, processing time is ignorable. Please calculate the channel utilization for sub-question stop and wait protocol and ARQ protocol if WT, the transmitting window size is 7. The third sub-question is if WT, the transmitting window size is 127. So before illustrate the answers, I will analyze the ARQ protocols. ARQ means the sender send several frames simultaneously. So if the window size is WT, here means the sender A can send WT frames. Here, WT, here, WT is what? Here, we assume the WT is 3, right? The 3, the 1, 2, 3. So here we assumed WT is 3. Because if in this graph, if I assume WT is 10, it should make the graphs too complex. So WT here is 3. Then the time length is the period of the first term is TS, the transmitting time of a single frame, TS plus 2TP, right? Plus 2TP. This red arrow means the first frame's acknowledgement for the first frame 1, right? The red arrow means the acknowledgement of the first frame arrived back to the A. So A will continue to the next term. So the length of the first term is TS plus 2TP, right? And in this term, A can send WT frames, right? Here, stop and wait, only one frames transmitted. But here, it can transmit WT frames. So the illustration is WT times TS, right? Plus what? Plus the length of the first term, plus TS divided by TS plus 2TP. This is the eta. This is the utilization of the ARQ protocol. So if you understand this equation, here I will illustrate the answers you can understand where. So here, the stop and wait, eta is TS plus TS divided by TS plus 2TP. So TS is transmitting time. So the length of a frame divided by data rate C. The TP is known, right? So the stop and wait protocol, eta is 1/251. Then if WT is 7, so only what you know is 7 times the utilization of stop and wait. Okay, 7 times this. So the 7/251. So if WT is 127, it becomes 127/251. So somebody asks if WT is 251, what is the utilization? So if WT is 1, so the fourth sub-question is if WT is 251, then the fourth question is eta the what? Eta is 1, right? This is 1. 1 means the utilization means 100%, right? So this is so if the fifth question, if WT is 300, what's the eta? Okay, eta should less or equal to 1. Eta is not larger than or larger than 1. So its eta is here. Eta is 1. Okay. Why? Hmm? If WT is 251, if WT is 251, that means the frames occupies the full time of this spare time, right? If WT is 251, that means the frames occupies the period of this term. So the utilization must be 1, right? And if the WT is larger than 251, that means at the best condition, the channel is always occupied by the successful frames. That means the utilization is 1, certainly, right? The utilization must not larger than 1, right? Okay. This is the questions. That is I prepared questions are prepared for chapter 3. Okay. If you have any questions, you can send messages in the WeChat group. Now I will illustrate questions for the MAC sublayers we have just learned. Question 1. In the Ethernet, the longest distance between two stations is 2 kilometers. The propagation speed of electromagnetic signal is 2 times 10^8 meter per second. And the two stations can be sure that there is no condition, there is no condition in this transmission only after what time point? In the Ethernet, the longest distance between two stations is 2 kilometers. Propagation speed of electromagnetic signal is V. Then the two stations can be sure after what? Which one is which one? Okay, I will illustrate at first. Now, in the Ethernet, the longest distance between two stations. So we denoted the two stations by A and B, right? By A and B. So the distance is denoted by Noakes air. Then the propagation speed of signal is, we denoted by Noakes V. We denoted by Noakes V. Okay, because V. Then the time is, the round trip time is too tall. Here, tall is the propagation delay. Propagation delay, tall, is the distance over what? Over the electromagnetic signal speed. Propagation speed of electromagnetic signal. So tau is air over V, right? Air over V is tau. Then the two stations can be sure there is no collision only after 2 tau. Only after 2 tau. So we can determine the 2 tau, right? 2 tau means 2 air divided by V. Here, air is 2 kilo, right? Air is 2 kilo, 2 kilometer, right? V is 2 times 10^8. Right? So the answer is 2 times 10 minus 5. So the answer is 2 times minus 5, right? The unit is S. Unit is S. So here the unit is mu S. So the answer is C. Because mu is 10 minus 8 S. Mu S is 10 minus 6 seconds. So after 20. Do you understand? So in the Ethernet, the two stations can be sure that there is no collision only after 2 tau. Tau is air divided by V. So if we know air and the value of V, so we can determine the 2 tau, right? 2 tau determined, so we can get the answer C. Okay, I will clean the screen. Look at the question 2. The minimum length of a valid frame. The minimum length of a valid frame in Ethernet is 24. Is 24. That is the specification. That is the specification of Ethernet. So we should memorize this value. So the minimum length of a valid frame in Ethernet is 4064. Question 3, 4064. Question 3, which one is not one of the characteristics of Ethernet? It's not one. It's not one of the characteristics. A CSMACD is or not the one characteristics. Is binary exponential backoff is one of the characteristics. Acknowledgement and retransmission for reliability is or not the characteristics not. So acknowledgement and retransmission for reliability is not one of the characteristics. So the answer is C. D, Manchester encoding for signal transmitting. Yes, it is one of the characteristics of Ethernet. So the answer is C. Now, let's next. Question 4. In one Ethernet, after the third condition, the probability that a station selects a random avoidance coefficient R with a value of 4 is which one? Is which one? After the third condition, the probability that a station select a random number R with a value of 4 is which one is bad? Is which one is the answer? Question 4. Question 4. The probability is which one? Which one? Okay, I will illustrate. So after the third condition, so I will denote it by the number is I. After the ith condition, after ith condition, here I is 3, right? Okay. If the I is 3, then The random avoidance coefficient R can be selected from 0, 1, 2, ... two with the power of I minus 1. So can be selected from the set of this one. From 0, 1, 2, ... 2 I minus 1 uniformly with uniformly probability. So select the value of 4 is how many numbers? How many numbers? Or what is the size of the set? 2 with the power of I, right? So anyone, select anyone from anyone among the numbers in the set is 1 over 2I, right? So I is 3. That is, the answer is B. Answer is B. Right? So let's have a rest. Let's have a rest for 10 minutes. Let's have a rest for 10 minutes. Okay, let's continue. Let's look at the question 5. Question 5 says, an Ethernet frame is received by a host and captured by Wireshark. Okay, we have used the Wireshark software for experiment 1. Then the first 32 bytes of the frame is as follows. With hexadecimal notation. The first 32 bytes of the frame is as follows with hexadecimal. That means the 32, the first 32 bytes. Okay, this is the nines. This is nines. So the first 32 bytes is F01, FAF 6, 7, 5, 2, A7, etc. Then the MAC address of this host is which one? This is an Ethernet frame received by a host and captured by Wireshark and displayed as follows. Which one is the MAC address of this host? That means from the content of the frame, we can determine the MAC address of this host. Which one? Okay. B is correct. B is correct. First, the length of a MAC address. The length of a MAC address is 6 bytes. 6 bytes. The MAC address has 6 bytes, right? The MAC address has 6 bytes, so A and C both wrong. So B and D, which one is better? Which one is the answer? Then, since the frame is received by the host, that means the destination MAC address is the same as the MAC address of this host. So, and the destination address is the first 6 bytes, right? The destination address is the first 6 bytes. So the MAC address of this host is the same as the destination address, right? This is the destination address. This is the source address. This is the source address. This is the destination address. DST, destination address. This is the source address, SRC, MAC address. So the MAC address of this host is the same as the destination address. So this frame is received by the host, right? So the answer is B. If the number is different, is changed in the final examination, I believe you can determine which one is the answer, right? It's very easy. Look at question 6. An Ethernet consists of 10 computers connected to a 100 megabps Ethernet switch. And which one is the bandwidth will be available to each computer generally? Ethernet, this question is some difficult for you. The Ethernet consists of 10 computers connected to a 100 megabps Ethernet switch. Here is a switch, not hub. And which one is the answer? The bandwidth will be available to each computer. 100 megabps, 10 computers. Then to each computer, what is the bandwidth available to each computer? Please choose the best. Please choose the answers. Please choose the answers. Which one? Which one is the answer? A, B, C, or D? I have found B, C, D. You have all chosen. Okay, the answer is D. Why is D? Why is D? Because this is a switch. Because this is a switch. Switch means each computer can get 100 megabps bandwidth. This is switch. Switch means each computer can get 100 megabps. So if this is not a switch, if changed to hub, if here we don't use Ethernet switch, but we use hub, then the answer is not D. If we use hub, then A is the answer. Right? Okay. If it is a hub, then that means 10 computers share the bandwidth of Ethernet. The answer becomes 10 megabps. But here, it is not hub, but a switch, right? So this is question 6. Do you understand? Okay. If you don't understand, you can memorize it. Question 7. The 3 forwarding mode of Ethernet switches are sorted in ascending order of average forwarding latency as the 3 forwarding modes of Ethernet switches are sorted in ascending order of average forwarding latency. That means that is which one has the least average forwarding latency? Which one has the longest forwarding latency? The least average forwarding latency is cut through. And Store and forward has the largest forwarding latency. So the answer is B. Answer is B, right? Segment free is between cut through and forwarding through. So the answer is B. Question 8. The forwarding network devices working at the data link layer is which one? The following network devices working at the data link layer, A, B, C, or D. Question 8. The following network device working at the data link layer is bridge, repeater, router, or gateway. Okay, thank you for taking part in the choice. But the answer is A. Answer is A. Network device working at the data link layer is a bridge. Bridge is a typical device at the data link layer. If this is a bridge, has two ports. One port connected to LAN, local area, LAN 1. The other ports connected to LAN 2. So the bridge as a data link layer device can connect to LAN, local area network. Here repeater can also connect to, but repeater works at physical layer. So repeater works at the physical layer. Router works at network layer. Gateway works at transport layer. Okay. Question 8. The answer to question 8 is A. Bridge. Bridge is a data link layer devices. Repeater is a physical layer devices. Router is a network layer devices. Gateway is a transport layer or physical layer, transport or application layer devices. Answer is A. Okay. Question 9. Question 9. For 100 megabps Ethernet switches, when the output port is not lined up to forward an Ethernet frame in the cut-through manner, excluding preamble and the frame start flag, the forwarding delay introduced is at least which one is bad? Which one is the answer? Which one is the answer? For 100 mega. For 100 mega BPS Ethernet switches, when output port is not lined up, so no accumulator key, that means not lined up. So with cut-through manner, then the forwarding delay introduced is at least. Okay, this question is difficult for you, so I illustrate first. So, okay, we assume that this is a frame, and this is a header. This is a header of a frame. Head. This is a header of a frame, and this is a CRC code. CRC code. This is CRC code. And this is 4 bytes. This is 14 bytes. And the first 6 bytes. This is the first 6 bytes. First 6 bytes is destination MAC address, right? This is destination MAC address. Destination MAC address. The first 6 bytes is destination MAC address. So for the cut-through manner, the switches received after 6 bytes received by the switches, then the switch know what is the destination MAC address. So after 6 bytes received, the switches can forward the frames by the destination MAC. So that forwarding delay, the forwarding delay is in fact the delay of receiving 6 bytes, right? So the delay is 6 bytes. 6 bytes, how many bits? 6 bytes, 6 times 8, right? 6 bytes, then how many bits? 1 byte is 8 bits. So 6 bytes or 48 bits. Then the rate is 100 mega, right? 100 mega. Mega means 10, 8, right? So the unit is S. So it is 0.48, right? 48 divided by 100 is 0.48 times 10 minus 6 second. So it is 0.48 milliseconds. Do you understand? So for cut through, after the first 6 bytes received, the switches can immediately forward the frames, depending on the destination MAC, right? Do you understand? This is cut through. Okay, next questions. Question 10. The following MAC protocol that confirms correctly received frames with acknowledgement is which one? Question 10. The following MAC protocol that confirms correctly received data frame with acknowledgement is which one? Which one of the following protocols has the acknowledgement mechanisms? Okay. The answer is D. The answer is D. With acknowledgement, only collision avoidance. CSMA with collision avoidance protocol. This MAC protocol for what kind of network? For wireless, right? Wireless. For wireless local area network. This is a collision CD without acknowledgement. So the answer is D. So these choice questions probably are difficult for you. Okay. So remember these knowledge points. Remember these knowledge points. And I suggest you read the textbook carefully. And read the textbook carefully. Then continue to the fill-in blank questions. Fill-in blank questions. Question 1. CD in CSMA CD protocol means collision detection. And the CA in CSMA CA means collision avoidance. CD means collision detection. CA means collision avoidance. Question 2. For Ethernet standard 10 1 base T, here base means baseband transmission. Baseband transmission. Baseband transmission, not passband. Here, base means baseband transmission. T, what is the T meaning? The meaning of T means the cable is twisted pair. Twisted pair cable is twisted pair cable. Question 3. If 10 computers are connected to an Ethernet switch, air switch of bandwidth 100 megabps, the average bandwidth available for each computer is 100 megabps, right? Because here, if the switch is here, if the switch used, then each computer can get the bandwidth of 100 megabps. Then question 4, forwarding mode of Ethernet switches includes here store and forward listed. So the other two are cut through forwarding, cut through and segment free. Cut through and segment free. What is the segment free? Since we have explained the cut through, right? Is a cut through here, cut through, that means after 6 bytes received, the switch begin to forward, right? 6 bytes. Do you understand? Cut through means after 6 bytes received, the switch can forward. Segment free means after receiving 48 bytes, 64 bytes, 64 bytes received, the switch begin to forward the frame. So this is 6 bytes. After 6 bytes received, but segment free after receiving 64 bytes. The store and forward means the whole after receiving the whole frame, the switches begin to forward. So they are different. So is a standing order of average forwarding latency is 6 bytes transmitting, 64 bytes transmitting. This is a whole frame transmitting, right? So I believe you have understand what's the difference between them. Question 5. Question 5. Among 3 modes of switches forwarding frames, which mode has minimum forwarding delay? Cut through, right? And which one has maximum forwarding delay? The store and forward mode. The store and forward mode has store and forward mode has maximum forwarding delay. Question 6. Wireless local area network uses an improved protocol for CSMA with acknowledgement and retransmission. Acknowledgement okay, with a collision avoidance and acknowledgement. Okay, the wireless local area network uses improved protocol for CSM with collision avoidance and acknowledgement. So today we have illustrated some questions for chapter 3 and chapter 4. So here now I will review the answers. Okay, the answers. The C, B, C, B, 5B, 6D, 7B, 8A, 9B, 10D. CD means collision detection. CA means collision avoidance. 2. Baseband transmission, twisted pair cable. 3. 100 mega bps. 4. Cut through segment free. 5. Cut through switching, store and forward is the maximum. 6. Collision avoidance and acknowledgement. And I will review the others. Review the other. One, for data link layer, chapter 3, C, 5 consecutive 1. The receiving window size 1. The maximum transmitting. If here is 3, then it's 7. And the utilization eta TS over TS plus 2TP is for ARQ protocol with different T transmitting window size. We can have this equation, and I have illustrated with this figure. Okay. That's all for today. Thank you. Bye. Bye.